everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to the technical session 7H. Myself, Shashwat Manitripathi, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 2025, Jaipur, India. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held on 15th December in Jaipur, India, and the virtual event is being held through Zoom yesterday and today, that is 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations and each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answers. On ninth minute, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or update, then you can write it to me in a chat box. Just before we start this session, I would like to introduce you to the chair of this session, Dr. Parth Shah. Sir is an associate professor at the Central University of Gujarat, India. His research area include information and network security, distributed computing, a computer architecture, and relative domains. He has a strong publication record with his work widely cited by researchers in the field. Dr. Shah is actively engaged in research projects and continue to contribute significantly to advancement in computing and secure system design. Now, I would like to start with a paper. Sachin Sen, paper titled AI-inspired cybersecurity and indigenous sovereignty, opportunity, risk, and pathway. You may please begin with your presentation.
Thank you, Mr. Shashwat. Can you see my screen? Hello?
Wait. Yes.
Okay. Shall I start now?
Yes, you can start.
Okay. Thanks for introducing about the conference. So I shall discuss about the AI-inspired cybersecurity for the indigenous sovereignty, that is for the Pacific Island states. So what are the opportunities, risks, and pathways while we implement AI-inspired cybersecurity systems? So rapid digitalization across indigenous and Pacific communities, expansion of digital services in the health sectors, banking, education, governance, the risk growing faster than local capacity because local capacity is insufficient, lacking the experience and lacking the technical capabilities. AI offers both promising protections and obviously the new vulnerabilities are arising when we apply artificial intelligence, that is AI. So cybersecurity, cyber risks in the islands, there is increasing cybersecurity targeting the cybersecurity attacks targeting the government and community systems. The attacks like phishing, ransomware, identity theft, online scams are growing. So limited national cybersecurity resources are causing the defense against those. And obviously, geographic isolation. These islands are geographically isolated from other countries. So they rely on the external systems, external infrastructures, external security providers. So AI-driven cybersecurity, the opportunities, side by side, the opportunities that has got concerns. So opportunity, I shall discuss some of the opportunities. Example, automated threat detection, predictive analytics for early warning, and faster and adaptive incident response. Those will be provided by implementing artificial intelligence inspired systems. So concerns are among the concerns. These are the main concerns. So algorithmic bias that affecting indigenous communities, over-reliance on foreign vendors, misalignment with cultural and ethical values, etc. So data sovereignty and legal challenges, which is a strong challenge. Data is often stored in the offshore, for example, the external providers, cloud providers, etc. Limited influence over data jurisdiction and governance, risks of surveillance, misuse, and data exploitation, need for indigenous-led data rights. To overcome from these, so they need the indigenous-led, that is Pacific Island states-led data rights frameworks. And all the problems are occurring due to their lacking of the expertise. So to overcome these systems, they need to build the capability and so encourage local solutions. So why those are occurring, this still lacking? Shortage of cybersecurity and AI specialists, obviously it is. Heavy dependence on consultants and foreign infrastructures, importance of upskilling youth and local ICT workforce can overcome the situation. Building community-based in digital capability programs, those can help in locally solution. So what AI can do? The core capabilities like pattern recognition, AI can help in recognizing the patterns, analyzing the behaviors, so autonomous decision making. So AI can transfer defense strategies for small nations with limited resources. Threat detection with artificial intelligence, AI. AI can identify anomalies in the network traffic. And learning from the past, AI can design the applications to combat with the attacks, to identify the risks, identify the vulnerabilities, so they can so defend the systems earlier and quickly. Useful against the attacks like phishing, fraud, insider threats. You know, their insider threats are more like about 70% compromise occurs from within the organizations. Enhances monitoring for essential services like health, telco, ports. Yeah. So those will be enhanced. Automated response and incident management. AI systems can quarantine the threat instantly, obviously. When they detect earlier, they can quarantine the threats. So reduces reliance on the human monitoring. So when 24/7 enables faster recovery from cyber incidents. Obviously it is automated systems. Particularly beneficial for resource constrained island states. Some of the attacks are very low scale, small scale, but impact is high value targets. Example, Pacific remittance. These states highly depend on the remittance, overseas remittance. So those are targeted, but that cause a high impact on their systems. Government registries and valuable for identity thefts. Health data increasingly digitized. When digitized, that means vulnerabilities are occurring. Okay. Attackers think that these nations are easy entry points. because they know that because due to the lack of their protection systems, cybersecurity protection systems, infrastructures, lack of money, they cannot build those protection systems, etc. Okay. So health data increasingly digitized, then attackers view a small nations like as a easy entry. That's what the attackers think. Okay. Sorry, I had a phone call. That's the interruption. Reliance on external internet infrastructure. So relying on the external infrastructures causing a lot of problems because that is out of their locally controlled systems. Regional dependence. For example, Australia, New Zealand, US service providers depend on the services provided by these big countries, the first world countries. Submarine cable vulnerabilities, cloud stress located offshore, like other countries like New Zealand, Australia, raises issues of digital sovereignty and surveillance. Challenges. Yeah, so AI is giving us opportunities, giving them opportunities, facilities to combat against the cybersecurity events. But at the same time, there are some challenges. The challenges include the inconsistent cybersecurity policy adoption, brain drain, which is a very common problem, limited budgets, lack of funds, low AI literacy, and limited digital governance structures. So those are the main challenges. Ethical AI and avoiding digital colonialism. Need to ensure the AI system reflect indigenous cultural values, avoid dependency on foreign technologies, protect the indigenous intellectual property, promote self-determination in digital transformation. That is indigenous-led system. So now I am going to the conclusion stage. I'll conclude soon. This project, so this will discuss about the AI implementation, how it improves and the challenges and pathways to come out of those problems about those. So AI offers major opportunities for Pacific cybersecurity, but risks include bias dependency and sovereignty loss. Locally grounded, culturally aligned governance is essential, and Pacific nations must strengthen partnerships and capacity. So that's all about this presentation. The final message is a secure digital Pacific needs indigenous-led, culturally grounded, and technically empowered. Thank you very much. Now, the
Thank
time
you.
for questions and discussions.
Thank you for your presentation. Sir, do you have any question?
From the audience if any question.
Yes, please. Not any questions?
Okay. See which aspect of security you are trying to focus?
The aspect of security means you mean
Which security service? I mean,
say cyber security. The cyber security of the infrastructures, their systems, etc.
yeah, that's okay. But there are specific security services like that data privacy and all, right?
Of course, that data privacy, not only data privacy,
Mm.
securing the system, securing the infrastructure, everything. Because I myself, I am a Cisco CCIE. I know how to secure the network, and I am a security expert. I worked for the New Zealand Telecom New Zealand in the security and networking area for 14 years, and then came to the academy. You know, so the security means securing everything. Which are the challenge. for this indigenous community, the islanders, small islands,
Okay,
lack of
tell us that
funds.
what are the possible risks on having a dependence on other countries?
Oh, obviously, when something not is in your control, you never know what can happen. For example, we store our data in the cloud, but cloud is not maintained by us. No?
So
So that
that is done by every country, no?
yeah, that
Most
is
of the
every
major.
country.
Hmm.
But here those small countries, they are mostly dependent. Not India, not New Zealand, not Australia, not USA. Everybody use other services like cloud services, other infrastructure, but you know they are smaller scale than those Pacific islands because those they do not have their local
Okay,
infrastructure.
okay, done. Thank you.
Are you happy with the answers?
Yeah.
Thank you very much. Anyone else, please?
Okay. So next we have,
Shall I close my slides?
yes.
Oh,
So
thank
next
you
we
very
have
much.
Krishna Prabha, paper titled AI-powered medical report analyzer and organ visualization. Krishna Prabha, are you there? Okay. So next we have Alok Agrawal, paper titled Customer Core Creation through Collaborative CRM Platforms, a systematic review of frameworks, technologies, and innovation performance. Mr. Alok, are you there? So next we have Manoj Kumar, paper titled Deep Violence Net, a VGG16 LSTM deep approach for automated surveillance.
Yes, sir, I'm here. Am I audible?
Yes, you are. You may please begin with your presentation.
Yeah. Is it visible?
Yes, it is.
Make it full screen, then stop.
Sorry, sir. Am I
And make
audible
it,
and visible?
yeah, you are audible. Make it full screen, the presentation, and then start.
Yeah. So thank you very much for giving me an opportunity. This is my privilege to present a paper in this conference. Uh, Paper title is Deep Valence Net, a VGG16 and LSTM deep approach for automated surveillance. This is mainly about recognizing or detecting human activity through video camera, through CCTV. So the presentation includes introduction, motivation, literature, research gap, objective, proposed methodology, result, conclusion, and the last references is also included. So here the point is violence when we go with violence detection. So violence is itself defined as a activity that is not acceptable in our society, that may cause some harm to both sides, or someone, specifically some organization, some person, some individual, or a group of person. So it may be defined as some psychological harassment and deprivation. So this all may be, this all are in the category of violence, and um, we are recording all this activity that is being happened in front of public place, in front of CCTV, that is on the public place, but we don't till now we don't have a automated system that could uh, uh, uniquely identify this is not permissible in this premises. So this is an approach to give an automated system that could uniquely identify which activity is not permissible in a specific campus, in a specific area, in a public place. So definitely we need to identify whether this is violence, not violence, or this is abnormal activity. So here we are trying for violence. So the motivation is uh, um, uh, mankind has been suffering because of violence across every country, and all we are now we are in the era of CCTV, digital era. So each and every activity is being recorded. So if there is an automated system that could uniquely identify if this is not permissible in this area, so definitely we need to localize it and send it message to some security person who is in charge of this area. So that's required. So this is the motivation. So uh, till till now we are just watching the uh, 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 screen and trying to localize a particular activity. It may be fall. Some elder person may fall on the platform, and through a screen we are trying to find out someone may fall at the camera number 34, and we are trying to provide some help. So if some system would be there which automatically identify and raise some alarm, may ask for help to that incident. So that could be possible, and this is the one of the approach for that. So some applications are required to detect of balance automatically. So this is the motivation because there are so many activity. For example, stampede that is happened in near in this year itself. 3, 4 stampede in India itself. Kumbh is one of them. Railway station stampede. If there would be a system which could be in at the starting, when there is a mechanism that could camera would start raising their alarm, so armed police force they'll definitely able to stop, and it could be um, not raised at that level that already happened. So this is one of the step, and there are so many persons they were doing that, but problem is uh, uh, uncut video. And when we are going for deploying at the site, so accuracy is very drastically changes, and this will become very low. So they have done so many all researchers they were doing uh, work, and one of the good data set is UCF crime. This is very uncut, realistic, and there are many challenges here. There is a problem of illumination. There is a problem of occlusion. There is a problem of no, this video UCF crime is a data set where this is very problematic. UCF 11 is another data set. These all are UCF 100. These all are the human activity data set where researchers they were trying to establish their pipeline of this set, their deep learning methodology to detect human activity, whether this is normal, abnormal, violent, there is some fire, and there is some assault, there is some different. So here we are focusing on violence. So many research articles are available that recognize violent activity based on handcrafted feature and deep features. Based on above mentioned literature, we have some potential research gap in this domain. Adaptation to dynamic environment, anomaly localization and explanation, real-time processing and scalability, long-term temporal modeling. These are the point where we are lagging. So we are trying to inculcate where we can deploy our model. So that should be small. So our main objective is to detect violent activity from a video. We have identified the following research objective for this work: to design and develop an algorithm capable of managing challenges associated with dim lighting, ambient noise, and background that can operate in real time on low power device. To design deep frameworks such as CNN, RNN, which extract the spatiotemporal feature to classify violent activity from a sequence of frame. So, proposed architecture where we have taken VGG with LSTM, and the finally um, classifier softmax will classify whether this video is violent or not violent. So input video is our input, and that is being converted into frames, and that frame size is 224 to 24, and that is the requirement of VGG 16. That's why we have converted that into a specific size. So now VGG 16 extract the feature from each and every frame, and they maintain a table in sequential way. So that could become the input for our LSTM in sequence manner, or it may be if there is a frame at t, so next frame is t plus 1. Next to that frame is t plus 2. So in this way, we are giving the input to LSTM, and LSTM is able to establish a relationship between consecutive of between the frames. So and at the last, softmax is detect whether this given video is uh, violent or not violent. So frame selection, there are 2-3 points where we could do something, and one of them is frame selection. So in this work, we have taken only fifth frame. Every fifth frame is selected. This is some other work. I have given some algorithm using fuzzy logic to select keyframes. But here I have taken only fifth frame selection to reduce if I take each and every frame, that would lead to redundancy. So that reduce the computational cost and maintain a representative video. So I have taken only fifth frame. And then VGG 16 model. This is a pre-trained CNN, and we have taken 13 convolute CNN layers and 3 fully connected layers. This is the benefit of VGG 16, where we are the 3 fully connected layer is available. So there is a less chance to uh, 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 reduce our features. So use as feature extractor. This is VGG 16. We have taken it as a feature extractor. Those features are being stored in a table in sequential manner, and then that is fed into
You have 1 minute to
LSTM.
conclude your presentation.
Yeah, LSTM and BiLSTM. So BiLSTM is forward and backward both. So data set we have used is Hawkified, crowd data set, and violent flow. So in flight Hawkified 900 videos, and crowd 750 videos, and violent flow we have 3500 videos. We have done it with Python. Use RTX 3090 GPU, and Ubuntu is there. So result is that we have a data set, and with VGG with LSTM and VGG plus BiLSTM, and we see that BiLSTM is achieving more accuracy. There is a problem in BiLSTM to inculcate to stop something to extract the feature. So will going less. So we have compare with CNN plus LSTM, separable CNN plus LSTM, CNN plus RNN, and VGG16 plus LSTM, VGG16 plus LSTM, and here definitely VGG16 plus LSTM is achieved 98.8, 98.5, 98.1%. So conclusion is this may be an effective balance detection method and suitable for real-time surveillance. So future work would be most diverse data set. We need to take CCTV footage, and we may work on that. And for violence, it could be seen that there are so many attacks, even 16, 11 or something. Is it possible to work on that by seeing the trend and finding the relationship on a very big video? So if this is possible, this could be a future work. And real-time deployment, again, this is one of the big challenge, and that would be done. So these are all are the references. So thank you. That's all from me. And now I'm open for question answer.
Thank you for your presentation. Sir, do you have any question?
Yeah. How much delay is there? Have you measured that? Delay in
So
terms of response.
if I go with only Hawkify data set, so delay is I think in 1.3 and 1 point something second. In other work, I have calculated that delay, but
Have you
here
done
I
any
have not.
experiment analysis on that?
Yeah, in other work, here I have not done. In this data set, I have not done, and even we have not done. So, but there is a delay, and if we deploy it in real time, there is a big delay, and there is a differences. We all provided this our set this our method on a publicly available data set. So that's why we have achieved that accuracy.
So suppose in place of taking only fifth frame, every fifth frame,
Yeah.
if we take all the frames for the detection, right?
Yeah,
Then what would be the
that
computation complexity?
that exponentially enlarge, it exponentially increase, and the problem is that even collab is collapsing with RAM. So we are not able to do that. If we are taking some method to select the key frame, then it would be possible. Even I have selected the key frames using fuzzy logic, where there is a less number of frames. For example, of 5-minute video, we are trying to select only 40, 50 frames. So that video may be represented by 40 to 50 frames. Even though there are so many 120, 150 frames
So why
should be
only
there.
fifth, not fourth or sixth?
Yeah, no, we could go through that.
No.
This is
See,
one of the
if you will take the fourth frame, no, so number of frames
yeah
would be increased.
yeah
And if you will
definitely.
take every sixth, then the less number of frames.
That less that is trying. My objective is to focus the final total number of frames should be 40 to 50. One video may be represented by only 40 to 50 frames, so that the resources would occupy, and we will able to do that performance or implementation. That's the resource constant. If we have the very good system, then definitely all frames need to be go through, and that would be beneficial.
And if the video is of 1 hour, then?
That's again very good
So
big
you
issue.
please think on
Now,
this.
point is that we need to cut those video. If we for example, there is CCTV, and we are analyzing whether there is a frame that could have some abnormal activity or there is a violence in that frame. So we could localize those frames. So this is the we have trained our model on this small video, but we could deploy it on a continuous stream of video, stream of frames. So it's not required a specific video is of 1 hour. If there is an activity, we may train that our model and apply it on a continuous video. Got it, sir?
Okay. Yeah. Good
Okay. Thank
presentation.
you. Thank you. Thank you.
And next we have Jenny Goyal, paper titled Estimating Yoga Benefits Using Machine Learning and Multimodal Data.
Hello everyone, good morning. This is Shashwat Srivastav here, one of the authors on the paper and one of the students working under Jeannie Goyal ma'am. So I'll be presenting the paper today.
Okay.
All right. Yeah.
You may please begin with your presentation.
Hi, Shashwat. This is Alok.
Hello. Am I connected to the meeting?
Yes, you are.
I'm so sorry. I was having a little bit of a network connectivity issue. Is my screen visible right now?
Yes, you may please start.
All right. Okay, so today I'll be presenting the paper Estimating Yoga Benefits Using Machine Learning and Multimodal Data. So I'll start with the introduction. So basically, yoga is widely practiced for mental and physical well-being, but most of the evidence of these benefits are subjective. Now, all of these evidences mostly are based on self-reports, surveys, or questionnaires. Now, what our work does, it aims to objectify yoga's quantitative benefits using physiological signals and machine learning. So, what was our motivation behind penning this paper? It was basically that modern life gives us a lot of stress and sedentary habits. Now, yoga is known to help, but it is hard to measure objectively, and most studies rely on self reported feelings. So, the gap lies on the data not being scalable, data driven, or there being objective validation on it. So now what we aim to do is we propose a multimodal machine learning framework that estimates yoga benefits using biosignals collected from wearable sensors validated through hybrid data set using a deep learning regression model. So this is basically an introduction and abstract. Now I'll come to what we are doing basically in this paper. So in this paper, we present a multimodal machine learning framework to objectify estimating the physiological benefits of yoga. We are integrating 5 biosignals here: EEG, ECG, EMG, and GSR, and SpO2 to capture complementary aspects of cardiovascular, muscular, emotional, and respiratory responses. Since no single data set contains all of these modalities, we have constructed a hybrid dataset by combining VESAR dataset along with EEG, ECG stress features from Kaggle and the SpO2 data from the IEEE health sensor dataset, using feature harmonization techniques to ensure that the data remains consistent throughout the dataset, since we are integrating 3 of them. Now, following, we do pre-processing, feature extraction and selection. We train a deep learning regression model based on multi-layer perceptron architecture to predict a physiological improvement associated with yoga practice. Experimental results demonstrate strong predictive performance of our model, indicating that the multimodal data fusion significantly enhances accuracy. Overall, this work provides an objective data-driven evidence of yoga's benefits on an average, and it establishes a scalable foundation for digital wellness monitoring and personalized health applications. Now, this is a basic abstract of what we have covered in this paper. Now, what we should take away from whatever literature surveys we have done is what is the novelty in our paper. What the previous papers have accomplished is that they have integrated more or less EEG data sets and shown what is the statistical improvement in health in yoga. For example, the first paper has done that it is an EEG based study, and it shows that the increase in alpha waves yoga leads to an increase in alpha waves, and the when the performing of yoga is constructed and using the average person, the alpha waves are decreased comparatively. What the second paper does is that yoga leads to increase in alpha waves and the meditation leads to an increase in theta waves. Now, what is the difference in the paper that we are trying to write and what is already available? The existing work does is that the sensors are basically single or dual. Either they have used EEG or at most EEG and ECG, or some other paper has used SpO2 sensor. Now, what we are trying to do is we are trying to integrate EEG, ECG, EMG, GSR, and SpO2 together in our study. Now, the data set these studies they have used one source. Now, we are trying to use an hybrid multi data set fusion. The method that they have used is statistical. What we have used is machine learning regression. So basically, the three reasons that we are trying to achieve novelty in our paper is we are using multi sensors. Our data set is combined using a lot of techniques and features, and our method uses machine learning regression to tell exactly how much help yoga does. So we now have a quantification more or less, and more work obviously needs to be done on it. So moving on, what is the related work done and what are the foundations in basic biosignal analysis? So this is just the write up and the nitty gritty details of whatever I've just covered. Now, what is our methodology? We start with consulting a specialist as to what are the yoga asanas that we should be focusing on, because of course we are using five sensors. So we should pick up the yoga asanas that specifically targets these five aspects of the human body. So then we get to data collection. So data we have collected from publicly available data sets, and then on it we have done pre-processing. Then we have scaled the features. Then we have split the data set into five existing data sets, and then on four we have done testing, on four we have done training, and on one we have done testing. Now, does it do early stopping, yes or no? Then on depending on that we go on, and then we have done our model evaluation, whether or not our ML model is able to stand up to what we are expecting of it. Now we evaluate on the validation fold, basically the testing. Then we aggregate the metrics, and then we do final test evaluation. Then we report on the metrics. So what does this do? So what the question arises is how we have integrated our data sets. Then secondly, what is our ML model? So I'll start with how we have done the pre-processing. In pre-processing, basically we have done the denoising because the data is available, it is very raw. So we have to pass it through bandpass and notch filters. Then we have normalized it using standard scalars and robust scalars. Then we have segmented it into fixed length windows. Now, for feature extraction from EEG, ECG, all of these, they are signals, basically biosignals. So, of course, Fourier transform helps us a lot in this. And what are the extracted features on which we would be doing the feature selection on? What is the EEG band power and asymmetry? What are the HRV metrics from ECG? What are the GSR, CCR features? And what is the EMG activation and average SpO2? Now, what happens in extracted features is basically we get a lot of raw data, then we extract something that means something out of it, and these are the five things that we have extracted out of the each multimodal data selection. Now, what are the features that we have selected? Since we are having so many features, we have the risk of overfitting. So, on all of these features, which are the best features which will show the best improvement, or we should use for our machine learning model? So to select the best features, we use this select k-beast algorithm with F score. Now, why we have used this? Because this algorithm tells us which feature has the maximum impact on the output, so that we are able to our ML model is able to work seamlessly along with the features, because of course we don't want the overfitting to happen here. Now, what is our model architecture? What is our ML model? Now we have extracted the features. Now we move on to what is our ML model. So we are using a regression model MLP. Our first from after the input layer, our first layer is dense 128 neurons. Then we go to leaky ReLU. Then we use batch normalization on it, and then so forth. Here is our where it is. Yeah. Input to 128 to 64 to 32 neurons, and then we are using leaky ReLU on each of them, and then we do batch normalization, then dropout, then linear output, and then we do the whole thing over again. So I have explained the pipeline right now. Yeah, I think I've explained the pipeline. Now, how do we do the evaluation? We used root mean square and then R square and then the other accuracy metrics. Now, again, what is the hardware that is being used in this when the data set is being collected? We have used EEG, ECG, GSR, SpO2, and EMG sensors. Now, what are our performance results? So, basically, let's look at our mean absolute error. Our mean absolute error gives us the absolute difference between actual value and predicted value. And on an average, our absolute mean absolute error is coming out to be 0.0117, which shows that our model's prediction is off only by approximately 0.01 units. Now, we are giving a very small error, around 1% in average. Then we go up to root mean square error. Now, what are the root mean square error helps us to penalize the large errors much more effectively. So, that is 0.0154. It shows us that the larger prediction errors are also still very small. Now, what is our coefficient of determination? Basically, R square. It helps us to explain how well the model explains the data. And basically, 92.64% of the variation in physiological improvement, our model is capturing that. So, our model is able to capture more than 92% of the physiological changes observed in the data. Then we move on to our project analysis. So basically, how this works. This is a use case diagram that we can use to make a data set ourselves by collecting data from people and from volunteers. So this is how we would proceed. This is a future implementation of this, and so is this. Basically, this is our the same pipeline in a
You
swim.
have 1 minute to conclude your presentation.
So what my conclusion would be is that this model gives us a robust data-driven evidence of yoga's positive impact on both physical and mental health, and utilizes advanced biosensor analysis. Then what are the different physiological improvements that we are seeing after yoga practice? So now we have an improved heart rate variability, we have improved oxygen saturation, we have a more balanced neural activity, and our stress indicators are a lot lesser. Now, of course, there are multiple real world applications to this. Basically, what we're trying to do is we are trying to create, number one, a data set that includes all of these models and all of the data from all of these sensors, which is usable somewhere, because we have done feature extraction and then feature selection on them. And the second thing is, now we are using the ML model to figure out what is the best thing that we can figure out, what is the best impact that it is doing. It has a lot of industry applications. Now yoga can be implemented into more of the clinical wellness programs. We can do corporate into corporate health initiatives, and etc etc. And here are the references that we've used for this paper. Thank you. If there are
Thank you
any
for
questions.
the presentation.
Yes.
Sir, do you have any question?
Yes, good presentation. My question is related to deployment of this application, right? So when you will deploy this application, at that time the sensor supposed to be remain connected to the person,
Yes, sir.
right? Okay.
Yes.
So I would just want to know, okay, for how many days you supposed to require that sensor to be connected to the person?
All right, sir. Now we are moving into the territory of how we would implement it if we were not using a public data set. So what we went on to figure out, we basically consulted a yoga specialist and we asked him what are the 3 or 4 asanas that we should use. So he gave us a list of basically Anulom Vilom, some other meditation practices, Kapal Bhati, etc., etc. Now, what happens is we were originally planning to, first of all, we have to integrate the all of these sensors using Raspberry Pi. What I mean at our level now, when this has some more future applications, obviously it would be done in a much more extensive manner. But what we were thinking of doing is we would use a Raspberry Pi to connect all of these 5 sensors, and then we would connect these sensors to a person for a minute, and then we would take the reading before they have done yoga and after they have done yoga, and we would take the data for a month so they would go through a minute or 2 minutes of sessions of each of the exercises that we have mentioned, and we would take all of the data for all 5 sensors for all of the exercises. It's not that Kapalbhati is focusing on bettering the brain waves, so we are only using the EEG data when we are doing Kapalbhati. We are taking all of the data when doing Kapalbhati, so we get a more generalized and a more normalized data that we can use almost everywhere. So this goes on for a month for each of the volunteer, and basically the whole session would last for 30 minutes every day, and then we would take that data and then deploy it.
Okay, good.
Okay. Any other questions?
So next we have Rima Gayatri, paper titled Hydrolyte Intelligent IoT Automatic for Soil-Based Watering and Light Regulation.
Good morning, sir.
Good morning.
I am Rima Gayatri from New Horizon College of Engineering. Thank you for giving me this opportunity.
You may please begin with your presentation.
Yes, sir. 1 second. Is my screen visible, sir?
Yes.
Yes, sir. Today I'm going to be presenting on the concept smart sensor. Our project title is Hydrolyte Intelligent IoT Automatic for soil-based watering and light regulation. These are the contents which I'm going to be explaining about. These are the contents which I'm going to be explaining about. It is basically, we have used hardware components and the software components together for a smart irrigation system. Hello? Am I audible, sir?
Yes, you are. Please continue.
Yes, sir. We are using hardware and software components for we have integrated for smart irrigation system. We have used basically various sensors. We have used various sensors for detecting the soil moisture and for light intensity and humidity sensor and other various sensors which can detect how the soil texture and how the plant can adapt the sunlight. If it is not adaptable, so we can provide the artificial light. This is our basic concept. These are the literature surveys. Literature surveys has various limitations which we have tried to improve on. High complexity, computational complexity, and high weight and everything. We have kept a lightweight components for which is easily transportable and which is easily carryable. These and Agricultural is a backbone for food security, employment, environmental employment, etc. Uh, so we are basically helping the farmers for easing their work by not completely replacing farmers, but then helping them out in certain ways, since they don't have much knowledge about how much water to plant water, amount of water that is required for the plant. Then during um, winter seasons and all, we there's no much sunlight, so we provide artificial light for it. This. These are the components we have used for in the hardware setup: a soil moisture sensor, a temperature sensor, humidity sensor, LDR sensor, OLED displaying for immediately displaying how the condition of the plants are, and gas sensor is basically smoke sensor, which we have integrated, which are not visible in much other papers, like other previously provided papers. And we have integrated smoke sensors when there are no when there are fire or smoke in a farmland. It basically detects and gives the output and we have pH sensor for the when there is a rain and etc. We detect, which is we alter the pH value. And we have used artificial light for artificial photosynthesis. It's not exactly matching the sunlight, but we have tried to integrate, so it is approximately equal to the amount of sunlight that we get. Then a relay module for the artificial watering. Relay module is used for artificial watering and etc. ESP32 we have used for controlling everything. And we have also created a website, IoT based website for dashboard for uh, collecting the data value and approximate values. These are the problem definitions: water over usage, then climate change, labor dependency, poor data usage, etc. These are the problems that are currently available, which we are trying to solve. And this is the objective. We are trying for an affordable and scalable product that is easily available for farmers, which is not quite expensive. And we have used multiple sensors for for the betterment of farm. And these are the proposed methodologies. Basically we collect the data from soil moisture sensor, temperature sensor, humidity, pH, light intensity in the field, etc. We use microcontroller to read the values and transmit the real-time sensor data in our dashboard. And after collecting all the data from the farmland, we use the dashboard for real-time data visibility. And this is the flowchart. This is how the model actually works: initializing the data, reading the data. If the soil moisture threshold is less than if it is less than the soil moisture, if the threshold is less, then activating the water pump. If not, we do not activate the water pump. Then we check for the light intensity. If the light intensity is less than the threshold value, we turn on the artificial light. And after doing all these process, we upload in the dashboard. These are the codes that we have used. We have used basically three coding.
Okay, so next we have Nikita Patil, paper titled Lane Line Detection for Solid and Broken Line in ADAS. Nikita, are
Hello.
you there?
Hello.
Yes, you may please begin with your presentation.
Yes, sir, please can you just give me some few minutes or you can start with the next presentation. I'll just download my PPT and keep it ready, sir.
Okay.
Yes.
So next we have Elista, paper titled Moduling Autonomous Border Surveillance System Integrating Movement Models and Multi-Agent Communication. Elisa, are you there? So next we have Amy Choksey, paper titled Privacy Protection in Recommender System and Mobile Crowd Sensing Using Prefusion.
Yes, sir. I'm presenting my screen. Just a moment. Is it visible, sir?
Yes, you may please start.
Okay. Good morning, respected chairperson, faculty members, and fellow researchers. I am Ami Choksi, and today I will be presenting our work titled Privacy Protection in Recommender System and Mobile Crowd Sensing using Prefusion. This work is carried out under the guidance of Dr. Ravi Gulati at Vir Narmad South Gujarat University. The focus of this presentation is how we can preserve user privacy while maintaining accuracy in modern data-driven system. So, the agenda for today's presentation will begin with the brief introduction to the recommender system and mobile crowd sensing. Then I'll be discussing privacy challenges, problem statement, followed by a proposed framework, experimental evaluation, application, future enhancement, and conclusion. So let me start with the introduction first. Recommender systems and mobile crowd sensor are integral to modern data-driven application. Recommender systems are widely used in the domains such as e commerce, healthcare, and personalized services. Mobile crowd sensing leverages distributed sensor enabled mobile devices to collect and analyze real world data. Despite their usefulness, both the systems rely heavily on continuous collection of sensitive user data, making privacy protection a critical challenge. As we all know, we all are using our e-commerce website in our day-to-day uses. Also, we are using our personalized health services. So, at the same time, when we are using it, we are compromising our data privacy somewhere. So, what are the sensitive data in both the system, that is recommender system and mobile crowd sensing, are personally identifiable information, user behavior, interaction history, location, mobility traces, medical and psychological data, device and sensor generated data, are contextual data such as time, activities, patterns, user frequency, aggregated preferences, and the recommended feedbacks. Leakage of such data can lead to identity theft, profiling discrimination, and regulatory violation. Inference attack, enabling re-identification even from the anonymized data. So, what are the privacy challenges faced in RS and MCSS? Inference attack. Inference attacks are the sensitive attributes inferred from the model outputs, such as, for example, some patient data are there. So when the output is generated from the model, they can find out whatever the data is there. Like, for example, the heart patient is there, so they can find the data from the output. So that will be violating the privacy rule. Membership inference in identifying whether users data was used in a training model. If someone find that this data is used inside the model, and they find out that, okay, we can use it to reconstruct our values, the reconstruction attacks can be also there. Centralizing storage risk is a very risky previously, when all the data was stored in a single server. So at that time, if that fails, everything will be damaged. The lack of the auditability, no transparent record of the data usage. If we don't have a good auditability, like who changes, who maintain the logs, so it will harm to our system. What is the problem statement? Recommender system and mobile crowd sensing application continues process high sensitive personal behavioral location and medical data, which makes them very vulnerable. So existing privacy mechanisms are often applied as an isolated one. So to provide a comprehensive protection while still maintaining our accuracy and privacy, we have proposed a privacy preserving framework, that is PriVusion, which protects our sensitive data through collection, learning processes without compromising the quality of recommendation and sensing outcomes. These are some of the literature review. We have done the comparative analysis over here, where the different method like differential privacy, federated learning, a combination of differential privacy and federated learning, decentralized learning, then deep learning and secure FL frameworks are used. But all have some and other limitations. Some are having degradation low, some are having formal privacy, but they lack the auditability. Some are having no privacy framework, limited privacy control, highly computational costs are there, no data grouping or efficiency are there. So our privacy preservation framework is addressing all these challenges and overcoming it. Next, proposed framework. Our Private Fusion is a unified private framework designed for the sensitive domain such as healthcare and mobile crowd sensing. This framework applies here K-means clustering, federated learning, decentralized training approaches used, DP, that is differential privacy, is used. All the all the model which are trained and update events are securely logged to the support transparency and traceability by using the blockchain. By integrating our clustering, federated learning, differential privacy into a single pipeline, fusion balances privacy preservation, model utility, and system reliability. So we'll start with the fusion, what it is exactly. So we have here the combination or a layered approach of K-means clustering, federated learning, differential privacy, and blockchain auditing. So we'll start with the K-means clustering. It just groups the similar users, and it is a first stage, that is an early abstraction. For the federating learning, to train our models locally, we use the federated learning, which will add some noises over here. Then we have a differential privacy, we have a blockchain auditing to ensure the robust privacy protection without significantly compromising prediction accuracy. We'll understand it in detail. So this is main workflow, how it will work. First, collecting of the data, then K-means clustering, then local FL training. We'll add the DP noise over here, and last stage will be the blockchaining logging, which will give us the global model aggregation. So this is how the system works flow. Now, this K-means clustering, where we group the similar data, it will reduce the data variability and improves learning stability. Instead of having a single record at a time, if we group the similar records, it will provide an initial layer of abstraction. In FL, we'll train the models locally on the distributed devices, which will ensure the sensitive data never leaves the source. It will reduce the risk with the centralized storage. Now, what is DP? Here we are adding a noise here. We are injecting a noise which will prevent inference and identification risk over here, which will give the privacy at the next level, because will add the protection by they will not able to identify us by adding the absolute value over here. Secure logging is there. This records model train and update activities. It supports transparency and traceability, enhance system reliability and trust. For that, we have used the blockchain. Integrated framework combines multiple privacy layers in a single pipeline. That's our Fusion. It maintains a balance between protection and accuracy. It is suitable for real world applications. So these are the stages, as I have told. For our this Fusion, we have used a medical generated data. This medical records are of 5,000 records are used, and for the key means clustering, we have used age, heart rate, blood pressure. These are just few of them. We have used according to the medical report. We have generated this, and for the federated learning, we have use here the decentralized computation, and for the differential privacy, we have used Laplace noise added to the model, and for the blockchaining, we have log all the our training. We have done all the whatever the models we are trained or updated. We have maintained it. So this is the experimental setup which we have used over here. As you can see, whenever we are adding the noises over here, okay, so as by adding the noises, the accuracy will be low, but we have maintained it. We have created a cluster of 10, and our absolute value, that is the differential, that is dp value, it is ranging from 0 to 10. And the blockchain algorithm which we have used is hyperledger fabric simulation. Now these are the key means clustering visualization. This all graph I have generated from the data set which we have used, that is the medical data which I have from that. These clusters are done on it. The cluster 1 shows the young and the normal vitals people. The cluster 2 shows the middle age, and the cluster 3 shows here the elderly high risk vitals. And this is the runtime versus the number of clusters. This shows that as in how we will add more number of clusters, this will actually, as in how we will keep adding number of clusters, it will trade off the privacy over here. It will not lead to a good result. So to balance it, we have add k equals to 10. That is a moderate amount of clusters we have used, so that it will balance the trade-off, that is runtime overhead, model accuracy, privacy preservation. And this experimental are accuracy, privacy, budget here means epsilon value, and the blockchain integration. So the original accuracy which was previously there, it was 94. With differential privacy, it was 92. Um epsilon value when it was 0.5. So the blockchain value and the observations are written. But the most important thing over here is, when we combine all this thing, we are achieving with a minor amount of like, if it was 94%, we are achieving it 92 percentage. So the privacy is maintained, the accuracy is maintained, and the security is also maintained. Now, what are the applications where we can use it? Our healthcare recommender system, most important.
You have 1 minute to conclude your presentation.
Okay, sir. We have healthcare systems, smart cities, IoT, personalized recommendation platforms, mobile crowd sensing, and our future work is to deploy more with the medical, that is MIMC3, which records we have taken, and advanced clustering we are planning, and interactive privacy dashboard will be there. And these are the references which I have used. Any questions?
Thank you for your presentation. Sir,
Yeah.
do you have any questions?
No.
Okay, sir. Thank you.
Hello. Hello.
Hello.
Yes, sir. This is Nikita Patil here, sir. I'm sorry for the interruption. Actually, I'm unable to share my screen, so I'll just share my PPT if you just provide me the mail ID, sir.
Okay,
So
wait.
that you can share it from your end, I can just do the presentation.
So next we have Kavi Balan, paper titled Smart Web Scraping and Market Analysis Bot using RE Framework and AI-driven approach for e-commerce intelligence.
Hello.
Hello. You may
Am I
please
audible?
present your presentation.
Yeah. Yes. 1 minute. Hello. Is that my screen is visible?
Yes, you may please proceed.
Oh, good morning, respected chairperson, honorable judges, and fellow researcher. My name is Kavi Balan from Department of Computer Science and Engineering. Today, I'm happy to present my research work titled Smart Web Scraping and Market Analysis Bot using RE Framework. It is an AI-driven approach for an e-commerce intelligence. Introduction. Today, e-commerce platforms like Amazon, Flipkart updates the price, discounts, and availability of multiple times. Tracking this manually is not practical and it's time consuming. But if you want to purchase a single product and we have to search on multiple e-commerce website, which will take time. Most people either checks prices randomly or depend on a static tool, which does not give the complete picture. To solve this problem, we are coming up with this RPA tool. In this project, we specifically use UiPath RE framework, which is called an Robotic Enterprises Framework, which provides a structured, reliable, and enterprises level automation architecture. The project aim: develop a web scraping bot using RE framework for readability and scalability, which reduces the time. Our system collects the product price, ratings, and availability from multiple website on daily basis by just giving a data in a simple Excel. For example, if you want any product, we want to compare with many website, we just give that a product name or a product title in Excel, which itself takes the product and compares with the multiple e-commerce website. The insights are sent to the email notification and visualized Power BI dashboard to the customer. To make the system more intelligent, we integrate the UiPath AI agent, which helps in adaptive changing website, where the website may change regularly by the developers. So it makes an adaptive change to the website and scraps the price. The project overview, it has the two part. One is called dispatcher, where the inputs are get in Excel and send it to the orchestrator, and a performer part, which is an RE framework, which has an inbuilt queue items and retry mechanism and logic details, executes the scrapping of the project from the queue, and then report generation compares today scrapped data with the previous history with an SQL database, and send an email notification daily to the stakeholders, highlighting the pricing momentum. We integrate the Power BI since it has the interactive dashboard, which helps to buy the product, and integrated an UiPath agent, which handles the dynamic web changes, adapting to the unexpected HTML structures and enabling the AI-driven anomaly. Uh, the previously existing system, manual monitoring of the competitor websites and price updates using the basic scrapping script, where the dynamic object manipulation may give the error, relies on the static Excel reports. The limitation of the existing system are time consuming, where we have to search manually on different platforms. A lack of real-time insight, since we are using AI driven approach, which gives the real-time insights. No integration. Existing system does not integrate on Power BI. It just give a normal HTML and poor adaptability. Since we are using RE framework, which has the retry mechanism, which retries 2-3 times and gives the proper real pricing. The problem statement: customers may, because of this limitation, user and business face the serious challenges. Customers find it difficult to track the price changes across multiple platforms. Business lack on adaptive, scalable solutions to compare the prices of a competitor. Since if we are the entrepreneur and we are selling the product, we can compare with our competitors, and we can set the price according to it, which helps as a business person to sell more products of our product. Existing tools, static or limited insights without daily comparative analysis. Importance of solving this problem. For customers, it helps deciding when and where the product to buy at the best price. For a business person, it helps real-time competitor intelligence, enables the better pricing strategies. Automation significantly reduce manual effect and time, improve accuracy, which reduces the time where in a single attempt we can get the price in multiple e-commerce website. And visual analytics to Power BI. Since we are using Power BI, it gives the trend analysis and daily alerts to the customers. And objectives, we aim to automate the data collection from multiple e-commerce platforms. We extract the key information like price, rating, stock status, and discounts of the two-day deal. Maybe like a Flipkart give the best deals like that, it will use through an email to our customers. The system is designed to handle a dynamic website changes where the website may change dynamically and regularly. The scope of this also include the generating reports and dashboard to support data-driven decision making. The key novelty of this project, instead of using simple script, we use RE framework, which is an robust and scalable, which is scrap regularly and queue-based in ordered way. The integration of AI framework, AI agent improves the adaptability to dynamic environment. Overall, the system compares with the RPA, analytics, and visualization in single solution, design a readiness for a future AI-driven anomaly detection. The challenge is the website may change dynamic of the layouts and HTML element, which will be handled by UiPath AI agent. Multiple website handling, which will be increasing the complexity and navigation of data extraction. And data consistency issue. Different platform uses different structured way that are handled by AI framework. And methodology, the requirement and analysis planning. Our methodology starts with the requirement analysis, where we identify the target website, and system design. Since we are using RE framework, which has the inbuilt design, we have to just include an AI agent for adaptive scrapping. And data acquisition, we are using an Excel sheet and send the data to the orchestrated queue. And error handling and recovery, we use try catch for an error handling, logging and notification, and adaptive AI. Data management, since we are giving a result in Power BI dashboard for the price trends, stock levels, and ratings, which automate the report generation to the user email on regularly. Deployment, we deploy this project in Orchestrator, continuous updates for adaptive scrapping, and scalable and intelligent end-to-end system. And this is a system architecture where user gives the input to the AI system, which is RE framework. RE framework sends the data to the orchestrator queue. With orchestrator queue, the RE framework takes the data and checks with the multiple e-commerce website and store the data in Excel sheet. With Excel sheet, we create a Power BI dashboard and send a notification to the user. It has a two-part. One is dispatcher, where the input layer get the data and send it to the dispatcher, and dispatcher stores it in a queue, orchestrator queue. In performer, it's take the data from orchestrator queue and validate and pre-process with the multiple e-commerce website and generate a Excel report. With Excel report, we update the Power BI dashboard and send automated alerts. If any layer fails, an adaptive AI layer monitor the site structure and adjust the logic and updates again. It retries multiple times. Result, since it has two modules, one is dispatcher, which takes the Excel and adds to the orchestrator queue, where the queue item status were tracked, new, in progress, successful, or if failed, it gives the failed, and it uses the retry logic. And performance module, it takes the product price, ratings, and availability. It handles using retry logic. Data was stored for a daily comparison and reporting. it is our error handling and recovery efficiency. Without RE framework, it takes 5.2 seconds, and with RE framework, it takes 2.8 seconds. And success rate was 96% since we deployed it. This is our dispatcher module, which takes the data from the Excel and it uses the multiple logic and send the data to the orchestrator queue. This is our queue where it has a product name and website to scrap. This is our performer part, which takes the data from the orchestrator queue and build a data table for Excel sheet output, and it scraps the product from the website. After scrapping, it extracts the data and store it in the data table. With that data table, the Power BI dashboard is formed. This is our system overview performance, where the successful rate is more than 85% and exception rate is 20%. Where this is our process: data extraction, data storage, Power BI generation, and email automation. Email automation to the user notification. So these are our literature survey, where we see some of them use the Selenium, which takes time consuming and which does not adapt to the dynamic web changes, and some of this. And thank you.
Thank you for your presentation. Sir, do you have any questions?
As the crawling is illegal, right? How you are going to tackle this problem?
Sorry, sir.
Web crawling is illegal. Scrapping, you are saying, no? That is illegal, right? You're supposed to take the permission before doing this. So how you will tackle that issue?
We bought APIs for scrapping website.
But that is also illegal. Anyway, look into that.
Okay, thank you. Any other question?
Okay. Next we have Krishna Prabha, paper titled AI-powered medical report analyzer and organ visualization.
Hello.
You may please begin with your presentation.
Okay, sir. Is my screen visible?
Yes.
Okay, sir. Good morning, everyone. I'm Krishna Prabha from Amrita Vishwa Vidyapeetham, and today I am presenting our work titled A Multimodal AI Framework for Medical Data Analysis. In healthcare, large amounts of information come from two main sources: unstructured clinical text and radiology images, especially X-rays. The challenge is that these two modalities are usually analyzed separately. As a result, clinicians often receive fragmented insights, and important connections between symptoms and imaging findings can be missed. Our motivation is to create a system that brings these modalities together in a single explainable AI driven framework. This not only improves interpretability, but also reduces the manual effort involved in going through lengthy reports. In this work, we integrate biomedical NLP, medical image captioning, and retrieval augmented generation (RAG) to analyze text and images in a unified manner. The system extracts key clinical entities such as diseases, symptoms, and anatomical regions, identifies relations among them, visualizes diseases severity,
and interprets chest X-ray images using an image captioning model. By combining these outputs, our framework provides complete and understandable clinic insights that support faster and more accurate decision making. Then coming to the methodology, our methodology is structured into several stages: data collection and pre-processing. We gather clinical text and chest X-ray images and normalize the data for analysis. Then biomedical named entity recognition. Using biomedical models like Sky Spacey, we extract entities like diseases, symptoms, anatomical terms, and severity indicators from text. Then relation extraction. So we use rule-based patterns and dependency parsing to identify how these entities are connected. For example, which disease affects which region of the body. So that's what coming under relation extraction. Then the anatomical diagrams using color indicators such as mild, moderate, and severe. A GPT-2 model is used to generate captions for chest X-rays. When multiple images are available, we analyze disease progression over time. Then coming to the rack-based clinical Q&A, using mini LM embeddings and face retrieval, the system can answer clinical questions based on relevant medical knowledge. Then finally, all outputs, text insights, visualizations are combined into a single interactive dashboard. Our results show that the system works effectively across both text and image modalities. The NER and relation extraction components accurately identify clinical information. The severity visualization provides clear and intuitive graphical insights. The image captioning model successfully describes abnormalities in X-ray images. The temporal analysis highlights whether a patient's condition is improving or worsening. The rack-based Q&A reduces the hallucinations and offers reliable medical reasoning. Together, these results demonstrate that a multimodal approach can significantly improve the clarity and usefulness of clinical data interpretation. To conclude, our research presents a unified multimodal framework that integrates text analysis, image interpretation, and knowledge-based reasoning. This system enhances clinical understanding, reduces manual effort, and provides a structured and explainable approach to medical data analysis. It shows strong potential for real-world healthcare applications where fast, accurate, and interpretable insights are essential. Thank you for your attention. Sir,
Thank you for your presentation. Sir, do you have any questions?
No question.
Okay. So next we have Alok Agrawal, paper titled Customer Co-Creation Through Collaborative CRM Platforms, a systematic review of frameworks, technologies, and innovation performance.
Hi, sir. Good morning. You are able to view my screen?
Yes, you may please begin with your presentation.
Good morning, sir, and the faculty. So my title is the customer co-creation through. Somehow I'm not able to remove this. Yeah, okay, cool. Sorry. Customer co-creation through collaborative CRM platforms. This is a systematic review which we have done as part of the framework technologies and innovation performance. I just joined. I'm the PhD scholar in Symbiosis International, Pune, India. So this is my first paper, which is more based upon the literature review and the frameworks. So I will begin my presentation. So there is a co-creation revolution which has swept through the world. Most of the studies which are for the CRM, the most of the studies which have been taken place are mostly in Europe and North America, and the other regions have still not done the co-creation revolution for the customers. What does co-creation means? That whatever we had the legacy CRMs, which is more like a business processes, they need to be propelled into a direction in which we can have the customer as well as the customer and the employees and everyone to be part of the entire ecosystem, which helps them to deliver the structured meaningful results, right? So what happens is that as part of the sales innovations, interaction tracking, and the early platform delivery, CRM systems currently are more based upon the legacy system, which is more inside the intranet, which are taking care of only the CSRs. But right now, the main intention as part of the global changes to have more agentic AI as well as the more people-friendly CRM, so that the customers can make use of it and help to interact to get more tailored research as part to get more tailored results as part of the interaction. So and as of now, we know that because of the advent of the technology, we have web interfaces, mobile applications, social media, Internet of Things devices, etc., which help us out. So as part of this review, we analyzed, we went through the Web of Science Corpus and Science Direct papers. We had 1247 articles which we reviewed, and this particular research paper is based upon the 34 studies which we concluded. I will go to. So there are some theoretical foundations which we have identified based upon the research study which has happened. They are the service dominant logic, resource-based view, social exchange theory, network theory, and psychological ownership theory. Service dominant logic is mostly about the customer co-creation, and it tells that there is an economic exchange which needs to happen if we want to utilize the skills and knowledge of the customers. The second is resource-based view and the dynamic capabilities, which says that how the companies or the organizations can outline the co-creation processes by integrating customer knowledge assets, which can include the SMS, which can include the various interactions which CRM has with the end customers. Social exchange theory also tell us that how can we have the principles which Mr. Ziong in 2022 had told that this was the first research on the social exchange theory which he did for CRM, to describe that what are the norms which we need to have to build the trust between the willingness of customer to come give the results, give the feedbacks, give the survey, uh, the positive and negative both, and which helps in and also we align it with the time. The fourth was the network theory, which tell us that how we will handle the interaction. So suppose when the customer comes, he says that he's not satisfied, and then we have the psychological ownership theory, which says that how we can do the co-creation participation between the customers and the. So this is the performance breakthrough which we identified through Hollebeck and Antonio. They had researched, and they said that the customer engagement increases if we have a co-creation collaborative CRM platform. The customer engagement increases, innovation success increases, and the customer loyalty increases much more, especially during the advent, especially when we are talking about the telecom customers. We know that there are the MNPs and all. MNP is the concept in which we can do the mobile number portability and all. We see that the customer loyalty has reduced, one small thing, and the customer moves to another issue. So basically, if we have co-creation, then it increases the promise. This is the technology stack which we wanted to highlight. So we have social CRM interfaces, idea management, collaborative filtering, and real-time analytics. So which tells us that web analytics, mobile apps, and social media integration, they form a big, major, broader customer engagement ecosystem. Then we have an idea management module, which tells us that the structured platforms which guide the customers through innovation stages. So basically, you do this, and then you get a next result. Then you can either do a gamification or you can do a next level. So that form of an idea management module, which can be derived on the fly. Then we have a collaborative filtering, which tells us that how can we use the AI models, etc., to get the unstructured feedback in the text, message, image, and video. And then we have the real-time analytics, which tells us that how can we involve NLP and other monitoring frameworks for the gamification and feedback loop. So the feedback has to be continuous. It cannot be that we do the complete thing and then we take the feedback, which will not help us in improving. This is the implementation frameworks, what we said. So we said that we need to have a staged co-creation framework, which tells that that we need to engage customers at all levels, right? From ideation phase to customer suggestion to analytics to development. Then we have customer capability framework, which was suggested by Mr. Holleback in 2021. He suggests that we need to have a co-creation activities with the things that customer can do and what motivates them. So there is no one shoe fit all. So we need to have identify the customer segmentation, and then we need to take care of the capability frameworks. Then we need to have a governance framework which tells us that what are the rules under which they work, which include the GDPR data, etc. Value measurement framework, which tells us that what is the effectiveness of the activities and what is the value, including the rate of participation and the contribution which they are doing, how much it is bringing value to the organization. And then we have the organization environment framework and the technology integration framework, which tells that how much CRM can be adopted, because adoption of CRM would involve cost and the effort. So how much it can be adopted according with the co-creation capabilities. This is the comparative analysis which we did for the co-creation frameworks as part of the CRM platforms. So in case it's an open innovation platform which we want to put as part of the framework, then the key components will be idea submission portals, voting system, collaboration spaces. Technology, what would be required is the cloud infrastructure, API, analytics tool. Benefits we will have is 38 to 45% increase. Implementation challenges will be that the IP management complexity, because it's an open innovation platform which requires dedicated moderation, since it's an open platform, so anybody can put anything, and we need to control it. And all these ideas were suggested by the authors, by the various authors which we support, which were the supporting studies, which I have put it as part of the last column. Same thing will go for the social CRM platform, gamification, gamified participation, crowdsourcing, collaborative filtering, and stage co-creation. All these frameworks can be embedded with CRM platforms, and CRM can be multi-modeled to make it more specific to be used across the region. Sorry, my time is finishing, so I will just speed through it. This is the multi-layered architecture which we need as part of the collaborative platform. So you will see that we have a structured approach which says that we need to have a foundation. We need to have an interaction layer which includes the layer. Then we have the analytics layer. Then we have the orchestration layer. We need the value realization layer and the governance shell. So governance shell will govern the entire body of the thing, and the various layers will identify that how we want to proceed ahead. So value realization layer is the most important layer, which says that how we can realize the value and how we can pull more customers, while all the orchestration layer, analytics layer, and interaction layer will keep on interacting between multiple applications and the surrounding systems of the CRM, and will try to analyze the data at the runtime to ensure that this works for the organization. These are the 5 pillars which we identified as part of the co-creation success. One was the participant recruitment, how we will motivate and bring the knowledgeable customers. So we don't want any fake customers or dummy customers. We want the motivated and knowledgeable customers who give both good and bad as well as the rational view, so that we can have that actual view that how organization should perform. We need to have a collaborative task structure which needs to tell us that how we can go from ideation to design participation, and we can do as part of service improvement. We need to have an incentive alignment which says that how we will have the tiered royalty programs and gamification alignment, so that people get attracted more to part of this co-creation, this thing which we will be doing as part of the organization. We need to have the knowledge articulation. This is the most important pillar of the co-creation success, which says that how we will capture and integrate customer insights. So customer can give a lot of ideas, but that how best and what is the maximum capacity we can include it, which keeps company profitable, as well as the customer happy. So we need to use the NLP models and the other AI models to have this analytical capabilities, which needs to be part of CRM. And then we need to measure the outcome, basically what is the ROI we will get after all the adoption. So these are the 5 pillars in which we want to have the co-creation success. This is the research landscape. So like I told, most of the research has happened in North America and Europe, which is quite quantitative and qualitative. Most of the research which has happened in Asia and other countries is more on the conceptual front and the mixed methods front. So that is the most important research which has happened on this front. These are some of the implementation challenges which we see. The technical integration barriers, that because ERP systems, CRM infrastructure, and customer channels, they are still being used as legacy. They are not still, lot of organizations have not increased or leveled up their CRM systems as per the new methodology. We have the data analytics complexity, which says that how we will, means how well and how sophisticated we can analyze the data using the NLP technologies, which are already growing like a rapid speed. So this will for sure help us, but we need to have its adoption also. Then we need to have the governance framework. Right now, the intellectual property rights, idea evaluation, contribution recognition, and all these things are not properly put as part of the governance framework, and the customers feel that they gave the input but they didn't get anything, or they spent their time but they didn't get a proper return. So those type of governance framework, or some of the customers feel like their idea is that their GDPR data is stolen. So those type of governance frameworks we need to put, and we need to give confidence to the customers. We need to have the organizational culture also to be built in. Still lot of companies we see and we discuss with them, say that they have the traditional employees, which says that we will decide what customer need, we will not tell what we need or what this. So they said that we drive the change. Ideal way in the real time right now post COVID, it is like customer drives the change and customer drives the policies of the organization. So this is an organization culture we need to bring, and privacy and security, like we said, that GDPR compliance and data protection policies. These are some of the key research insights. Co-creation duality. We need to have the value creation and value destroying behaviors. So we need to have this co-creation, that we need to create and destroy both the values, so that it helps us in the binary classifications. We need to have trust as the foundation. So like we saw, the foundation should be trust. Only when then the people will give the input. We need to have a transparency impact. So people should see that whatever they have given, they see a change, that if they've given an input, the people are following. A lot of times this doesn't happen in an organization. So this is one of the transparency impact which has to happen. And the hybrid contributions. So like we say that we need to have a valuable insights, privacy concern limits, and all, and automated plus active, so people can give on the hardware and on the hard copy as well as on the uh, these are the future research directions. So we say that we need to have longitudinal studies, boundary conditions, ethical frameworks, human AI interaction, and cross-cultural analytics. Longitudinal studies will tell us that we need to have dynamics over time to understand relationship evolution and long-time value. Boundary condition is, we need to, right now whatever research has been done is not taking into consideration various organization sizes, and they are mostly done by the big companies like AT&T and Sprint and big companies, but they have not been able to spindle through into the small companies like 3 Ireland or 3 UK and those type of companies, organizational telco companies. And because the resource rich firms funded the researches which have happened up till now. So that is one of the reason. Ethical framework, we need to have more ethical framework and fair composition, as well as intellectual property rights, which needs to have the future directions, which needs to have human AI interaction. Right now whatever studies which have been done has not involved much of AI, and it was more on the human interaction which needs to happen. So we need to create an optimal architecture around it. And cross-cultural analysis, like more on the Western and Asian countries, which needs to be part of it, because the population size here is huge as compared to European and American companies, and the thinking concept is different. So we need to have more cross-cultural analysis. And this is the path forward. We need to have the critical success factors, which we need is
You
the
have 1 minute to conclude.
yeah, sorry, this is the last slide. Critical success factors. We need to have a high level customer analytic capabilities. We need to have a intellectual property governance, workforce development, and integrated structure. And what we need is the service dominant logic, technological infrastructure, and organizational capabilities. This will help us in the path forward. These some of the study limitations which we had is that we reviewed only the English journals, and we put a particular time frame 2020 2025. We couldn't because before that we thought that the CRM was not that evolved as compared to the evolution which happened because of the COVID, when people became more online and they started using more online studies. So these were some of the study limitations which we have, and these are the references. Yeah, thank you.
Thank you for your presentation. Sir, do you have any questions?
No questions.
Thank you, sir.
Okay.
Thank you.
So next we have Nikita Patil, paper titled Lane Line Detection for Solid and Broken Lines in ADAS.
Yes, sir. A very good morning. Is my voice audible?
Yes.
Okay, sir. Yeah, a very good morning. So today we shall see how the lane line detection can be done for the solid as well as broken lines in the ADAS. Okay. Yes. Let's move to the next slide. Hello.
Yeah, I'm sharing.
Hello. Yeah. Can you just share the? Change this. Yes. Next slide. Next slide, sir. Yes, sir. So as we all know that it is one of the lane line detection is one of the basic problem in the computer vision, which tries to involve identifying the edges of the driving lanes in the road images or as well as the videos. So the main goal here is to detect as well as track the lane markings in the real time, even during the difficult situations such as light glow, glare, or shadows, or complex road shapes. So the motivation here was since it plays a very crucial role in guiding the vehicles as well as ensuring the road safety, then trying to differentiate between the solid as well as broken lines is very important for obeying our traffic rules. So many existing there are many lane existing detection methods which where we are going to use the deep learning techniques, which requires almost the high computational power and the costly hardware. So there is a need almost to design for the fast low cost lane detection system which can work for the real system in case of the ADAS applications. So shall we move to the next slide? Hello. Yeah. So this is our problem statement, what we had designed. To find out a solution for this. Okay. So there are still many existing approaches which were not suitable for the to design for the low cost automotive systems. So hence we are thinking of designing an efficient and lightweight computer vision based solution which is required for almost the real time lane detection in case of the ADAS. So shall we move? Okay, so the objectives here to design the system were to detect the lane boundaries accurately from the road images as well as the video sequences, and to differentiate between the solid and broken lines using the computer vision techniques, as well as to achieve some real time lane detection with a low computational complexity, then have some reliable performance under different road and lighting conditions for ADAS applications. So next slide. Yes, so this is the basic functional diagram what we had followed for design of our system, where we consider camera as our input, provided to do the frame extraction cover, where we'll be trying to isolate the individual frames from the video. Then we'll just try to pre-process the images, that is enhancing the image quality for the analysis. Then we'll provide some edge detection techniques, that is using canny edge. Okay, so identifying the edges in the image. Then we do some ROI selection. Then finally, through the Hawk transform, the lanes will get classified. We are trying to visualize and provide it to the system, what we call it as ADAS out. Next slide, sir. Hello. Hello. Hello.
Already done.
Hello.
Hello.
Yes, yes. Okay, okay. Now I'm able to see it, sir. So it consists of, as I have already explained, these blocks over in my previous picture. Yes. So next. Okay. Yes. Again, this is like just like a flowchart for detecting the lanes, where we will be using a single CCD camera, which will be mounted on the vehicle's front windshield. Then the lane detection camera can identify the lane markers in the real time. The system first tries to load the input file, which can be earlier an image or a video stream. Then here each video frame is then tried to analyze and sequentially ensuring the conditions or continuous lane recognition. So we are going to apply several filtering steps which are applied to enhance the quality of the input image. Then the image is then converted into the single scale grayscale format to reduce the computational efficiency. So after pre-processing, the edges are almost extracted from the filtered image using the canny edge detection principle or the algorithm. Yes. So can we go for the next one? So this is the overall flowchart of the lane detection ka principle. Yes, and this is the proposed methodology what we had tried to use. That is determining its ROI. Then where the region of interest is selected to focus mainly on the road area where lane markings will be present. So it tries to remove almost the unnecessary regions, such as it can be a sky, buildings, or nearby vehicles. Then the main processing part will be done using the Gaussian filter. The noise will be removed, almost reduced. It cannot be completely reduced. Yes. Next, can we go for the next one? Yes. Then try to detect the line segments as well as identify the line type. Yes, sir. Okay. So finally, we'll turn into the decision making, such as if it is a solid line detection, then there is no overtaking which is required. If it is broken line, yes, almost overtaking is allowed. Yes, so these are the results as well as the performance. So we tried to almost achieve an accuracy of 98.3 for the solid line markings. For the broken line, we tried, it was 92.7. The system does try to achieve the real-time performance with the processing speed of some 48 frames per second on the CPU-based hardware. Next. Okay, so these are the images what we had detected, and as well as it was done for the video also. This is the sample results or the table which tells us about the frames or the total processing time. Then what is the achieved time for this processing speed for this? So can we go for the last almost? Yes. So the conclusion, what we could say here is it was finally successfully implemented and evaluated on the multiple video samples with some varying levels of complexity. Thus, our experimental results tries to prove that real-time performance in case of the normal road scenarios with the frame rates of almost 48 and 27.8, satisfying real-time video processing requirements. Yes. Now. Yes, it is almost a software ka work what we have done. So the same thing we need to just try it on the hardware and check out. Yes, thank you.
Thank you for your presentation. Sir, do you have any
Yes, sir.
questions? Sir?
No.
Okay.
Thank you, sir. Can I leave?
Wait.
Yes.
I sincerely thanks our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of our whole team, thank you for the support during the 10th edition version and all the 9 previous versions of the conference. We will be happy to have you in a 11th conference in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTCS 2025. Now, I also thanks our session chair, Dr. Parth Shah, for chairing this session. A token of appreciation to the chair on behalf of Team ICTCS 2025 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, sir. Would you like to share a quick closing remark with us?
Yeah, thank you for the providing me opportunity being a session chair over here. The overall quality of the papers are very good, and all the participants have successfully presented their work. Thank you.
So now I kindly request you all to switch on your camera for a quick snapshot of a virtual conference. Thank you. Stay safe and take care.
Thank you for the opportunity, sir.
The opportunity, sir.